Hello, my name is Matthew Phillips. I'm the VP of Business Development for NWave, and I spoke about the different types of wireless networks that can be applied to the Internet of Things. So NWave is a very, very small company, but we also have developed a wireless network for the Internet of Things, and I thought I'd just come and talk to you a little bit about some of its characteristics and just really give a summary of where we see the positioning for the network relative to our competitors and other solutions that have been talked about this afternoon. So in the spirit of starting with if you like, the pitch, I'll start in the same vein as the previous speaker. We start with this slide, of course, the Internet of Things. I think everybody here, we all know the opportunity, the billions of devices, and why we're all gathered here is to see how we take this idea and realize it into real working and actual networks. So, and this is where I say you may have already heard this afternoon. At NWave, we thought, well, okay, what are the main characteristics we need for wireless connections that will sustain truly all these different applications, or many applications, within the Internet of Things. And we came upon 4 qualities which we felt were important as you look at how you would utilize wireless connections to realize real applications. And I'm surprised to say that the 4 categories are exactly the same as the 4 categories you saw from the previous speaker. So no, that's fine. Actually, I think it's a tremendous validation that probably we're both on the right path, as it were. So long battery life, because these devices you need to be able to fit them and forget them and not constantly changing batteries, or they need to be able to use energy harvesting as power sources. I think the arguments for long battery life are fairly obvious. Long range, because again, we also felt that mesh networks and things with gateways and other things add lots of complexity which actually detract from the feasibility of really scaling and really building these networks with the capacity that's needed for many of the applications that people want to use them for. Cost, and I totally agree with the previous speaker on the cost models and the sensitivity of the applications to costs. And similarly, today you see GSM GPRS modules have a certain cost, and there are many applications which need to go beyond that and go lower. And so we see the need to focus on device cost. And of course capacity, and I also agree that within the coverage of each base station, we also believe you need to be able to address hundreds of thousands of devices within the coverage area of a cell. So yeah, I think all I can say is that the logic of what we of the arguments that were just made, I think NWave also totally see the same things as being critical in how you might implement a wireless technology to be truly useful and to bring about all of the applications which the Internet of Things promises. So starting from the point of, well, what wireless solutions could we use that fulfill those criteria? And I'll flick through the advert, but the graphics are entertaining anyway. So if we look at battery life, we took away some of the potential candidates. And if we added the long range requirement, we got rid of a few more. And if we have the cost requirement, we got rid of those. And I guess I could have had another box, but you did say you only finally agreed last week, and I wrote this slide more than a week ago. So I'm left with 2 potential candidates in unlicensed spectrum. And as I think I'll try to show this afternoon, if I apply the capacity criteria, then I might also do that. Which sort of leads me to the nub of where we see NWave fitting in. Now, NWave actually does use an open standard called weightless. Weightless as an industry group has had quite a long history now around the Internet of Things, but essentially the technology that NWave developed is the basis of the weightless N standard, and so it's an open technology, and you can go and get the specs and develop products based on that technology quite openly as part of the weightless industry group. So I'll just mention that. So that's one thing which we see as an advantage. So if I rather controversially sort of said, and these two, which the speaker also talked about, why did I say about capacity? And I think if you look at the technical criteria, and I'm sorry this slide is a bit technical, but fundamentally if you look, you see that in particular, well, Weightless and Sigfox are both low bit rate technologies with very narrow bandwidth. It's fundamentally the trick is by keeping the bandwidth of the transmission very small, essentially you can make the link budget very high from moderate levels of transmission power, and because you can have moderate levels of transmission power, you can extend the battery life of the devices using those networks. So it's all fundamentally, it's very, very classical wireless theory. And if you talk to any radio amateur, he'll tell you that Morse code, which is also extremely narrow, is very, very good at transmitting all the way around the world on very low power, when you only have small amounts of information to send. So the idea of using very narrow transmissions to conserve power and provide long range is not particularly new. LoRa is using a direct sequence spread spectrum methodology, which means that the channel bandwidths are higher, so it uses 125 kilohertz channel, and then it uses the spreading, the process gain from the spreading action to effectively achieve a high link budget. And it does have the flexibility to vary data rates. So you can have very low data rates up to slightly higher moderate data rates. But that will also give you changes in the effective link budget that the system offers. So all three networks fundamentally give you, when you look at it, roughly similar link budgets and therefore range versus their power consumption. But I think what's different perhaps is in the area of capacity. And the reasons for that are fundamentally that in the Sigfox case, their base stations tend to look at a block of spectrum, so 192 kilohertz of spectrum. And then within that 192 kilohertz, there are lots of narrow channels, each carrying individual transmissions from outstations. So that tells you that if you're looking at 192 kilohertz of spectrum and each channel is 100 hertz wide, then you can see 1,920 simultaneous transmissions at any one time. And then depending on the duty cycle of all the different stations within the coverage area will tell you how many devices you can support. Now, in the weightless implementation that NWave have done, we can look at 2 megahertz of spectrum simultaneously. So you can do the same math and come to the conclusion you can look at 20,000 simultaneous transmissions, and therefore effectively you can have a much higher capacity. It's about 10 times the capacity per base station, which easily equates to more on a typical usage of a few bytes of data once per hour, easily equates to more than 500,000 devices within the coverage area of one base station in a weightless network. Now, in LoRa, obviously you have fewer channels because you have channels that are 125 kilohertz wide. So in a megahertz of spectrum, you get 8 of those. And therefore, stations must share frequencies. They must be co-channel, essentially more than one station active on a frequency at any time. And the system segregates those into the individual data channels using the spread spectrum. But you only get about 9 dBs of rejection. So actually, if you get a lot of stations simultaneously active on the same radio channel, each with different spreading codes, it's quite easy to quickly build up the noise floor in that channel and effectively to then miss transmissions and to lose communication. So I would argue that direct sequence spread spectrum is pretty well known for achieving great link budgets. I mean, GPS uses quite similar sort of technique, and you know, the satellite with signals are very, very weak when they get on the ground. But it does have this downside that the co-channel rejection of the relatively limited amount of spreading that's done is not particularly high, and you can get channel overcrowding quite quickly. So that's why I sort of argued that, you know, you can take these three systems and look at them, and they all are slightly different, but we felt that we made the right choices around link budget to get range and power consumption and also capacity. And these can be deployed, I think, I'll move on and talk about that, but these can be deployed in a relatively low cost and non-optimum radio locations. So it is effectively possible to deploy networks right now to do many things within smart cities environments and meet all of the criteria which I think we just have seen on the panel agreement from different speakers. So I just looked at final slide today. Just looked at the different deployment models. Certainly Weightless N and LoRa are sort of adopting a more ad hoc deployment model. So you can roll out networks based on those technologies on just a campus, or maybe a city, or a region, or of course you can do national networks, as was described by the first speaker. They can be rolled out for specific applications. One of the applications which was mentioned this afternoon is smart pallets. So you can put a base station in a certain area where you have a lot of logistics activity, and you can track the flow of pallets on trucks, off trucks, and wherever they go. Obviously, these networks can be publicly operated, they can be privately operated, and they can be closed to a particular user who owns that network, or they can be open and carry lots of traffic. I think we've seen that Sigfox has adopted a more telecom or operator type rollout, so choosing particular partners in particular locations and creating area coverage with that selected partner that then people are encouraged to build applications upon. So much less a sort of ad hoc deployments and more sort of country by country or region by region with a suitable partner. And that, I think, has benefits in the sense that, of course, if you're developing an application and you're in the area where there is a network that covers, then it's very easy to get going. You don't need to worry about putting your own infrastructure in. And on the other hand, if there isn't a network, well, you may have to wait longer before one arrives. So there are pros and cons in those deployment methods. So that's probably as much as I wanted to say this afternoon, just to really contrast the three types of network which are deploying in unlicensed spectrum. I think each has its strengths and weaknesses. Obviously, NWave's and Weightless weakness is that we're probably the third in terms of what people know about, and that's something that, you know, as a company we have to address. But I think there are other advantages to what we offer. And with that, I've probably finished for this afternoon. Thank you.